Welcome. Today we solve LeetCode 2904, shortest and lexicographically smallest beautiful string. We get a binary string S made of zeros and ones and a positive integer k. We must find the shortest beautiful substring. If several share that shortest length, we pick the lexicographically smallest. If none exist, we return an empty string. We will go slowly from zero. What does beautiful mean? A substring is beautiful when it contains exactly k ones, the digit 1. Zeros are allowed in any amount. Example, if k is 2, then 1 1 is beautiful and 1 0 1 is beautiful. A single one is not, because that is only 1 1. 3 ones in a row is not, because that is 3 ones, not exactly k. There are two goals, and order matters. First, among all beautiful substrings, find the shortest length. Second, among all beautiful substrings that have that shortest length, pick the lexicographically smallest string. Third, if no beautiful substring exists at all, return empty. Never optimize dictionary order before length. Length always comes first. Lexicographic order means dictionary order for strings of the same length. Compare left to right. At the first position where they differ, the smaller character wins. For binary strings, 0 is smaller than 1. Example, 0 1 is smaller than 1 0, because the first characters are 0 versus 1. We only use this tie break after the length is already fixed. Quick reminder, a substring is a contiguous slice, consecutive characters with no skipping. From 1 0 1 1, pieces like 1 0, 0 1, 1 1, and 1 0 1 are substrings. Picking the first one and the last one while skipping the middle is a subsequence, not a substring. This problem only cares about contiguous pieces. Example 1s is 1000, 11001. K is 3. The output is 11001. There are several beautiful substrings with exactly 3 ones. The shortest length among them is 5, and the lexicographically smallest length 5 beautiful piece is 11001. Look at some candidates. 100011 has length 6 and 3 ones. 011001 also has length 6. 11001 has length 5. That is shorter. Longer pieces like length 7 also exist, but length 5 beats them. Shortest length wins first. Example 2s is 1011, k is 2. Beautiful substrings, 101 length 3, 011 length 3, and 11 length 2. The shortest length is 2, and the only length 2 beautiful substring is 1 1, so the answer is 1 1. Example 3, S is 000, K is 1. The string has no ones at all. We need exactly 1 1, which is impossible. So there is no beautiful substring, and the answer is the empty string. Always handle the not enough ones case. Constraints. The string length is at most 100. K is at least 1, and at most the length of S. The string contains only zeros and ones. Because n is tiny, an O of n squared solution is perfectly fine. Prefer a clear idea over a fancy micro-optimization. Naive idea that works. Check every substring from left to right. Count how many ones it has. If the count equals k, it is beautiful. Keep a best answer. Prefer a shorter length. If lengths are equal, prefer the lexicographically smaller string. With n at most 100, this brute force is valid. Smarter insight for the shortest answer. Any shortest beautiful substring must start and end on a 1. Why? Extra leading zeros or trailing zeros only make the string longer. They never help length. So every shortest candidate is exactly from the ith one in the string to the I plus k minus 1th one. Step 1. Collect ones. Take S equals 1000, 11001. Mark indices of every one, 0, 4, 5, and 8. So the ones list is 0, 4, 5, 8. We need windows of k equals 3 consecutive entries in this ones list. Slide windows across the ones list. First window, ones at 0, 4, 5. Substring from index 0 to 5 is 100011, length 6. Second window, ones at 4, 5, 8. Substring from index 4 to 8 is 11001, length 5. Each block of k1s in the ones list gives one candidate. Pick the winner. Length 6 versus length 5. 5 is better, so keep 11001. If two candidates had the same length, we would compare the strings themselves and keep the smaller one. Update the answer whenever you find a better length or the same length with a better lexicographic order. Algorithm steps. 1. Collect all indices where the character is 1. 2. If you have fewer than k ones, return empty. 3. For each starting position I in the ones list, take the substring from ones of I to ones of I plus k minus 1. 4. Keep the best by shorter length, then lexicographically smaller. 5. Return that best substring. Code sketch. Build ones as every index I where s of I is the character 1. If the length of ones is less than k, return empty. Initialize answer as none. Loop I over every valid window start. Set cur to the slice from ones of I through ones of I plus k minus 1. If answer is empty, or cur is shorter, or same length and cur is lexicographically smaller, set answer to cur. Return answer. Walkthrough of example 2. S is 1011, k is 2. Ones list is 0, 2, 3. First window from index 0 to 2 gives 101, length 3. Second window from index 2 to 3 gives 11, length 2. Better. Answer is 11. Same recipe every time. Why skip extra zeros outside? Look at 0011001. It has 3 ones but length 7 because of leading zeros. The same 3 ones already sit inside 11001 of length 5. Trailing zeros likewise only lengthen. For shortest length, shrink to the first one through the last one of that window. When two beautiful substrings have the same length, break the tie with normal string compare. Walk character by character and keep the smaller. In binary, at the same length, a string that has 0 earlier beats one that has 1 at that position. Remember, this only happens after the shortest length is already chosen. Common mistakes. Choosing the lexicographically smallest string before checking length. Counting zeros instead of ones. Accidentally allowing non-contiguous subsequences. Forgetting to return empty when there are fewer than k ones. And off by 1 when slicing, the end index is ones of I plus k minus 1, inclusive. Complexity. Time is about O of n squared in the worst case, up to O of n windows, and each copy or compare can take O of n. With n at most 100, that is tiny. Space is O of n for the ones list and the answer. Brute forcing all substrings is also fine at this size. Alternate approach. Nested loops over left and right, maintain a running count of ones, and when the count equals k, update the answer. That also works. For the shortest answer specifically, the ones list window method is usually the clearest to explain in an interview. Either approach is acceptable here. Takeaways. Beautiful means a substring with exactly k ones. Optimize length first, then lexicographic order. The shortest candidates are windows from the ith one to the I plus k minus 1th one. If there are not enough ones, return empty. Binary string, count of ones, 2-level compare. You got this.